Hey everyone, and welcome to the third lab of Physics 2 regarding circuits. For some introduction, the purpose of this lab is to use loop rule to predict RC and DC circuit behavior in real life and virtually by measuring potential differences, conventional currents, ohmic capacitors, and resistors, and we do this online using a PHYS simulator and real-life multimeters. Okay, so on to some of the fundamental concepts underlying the physics of circuits. Firstly, we have the potential difference of a resistor in series and parallel, as well as the potential difference of a capacitor in series and parallel. Next, Ohm's law states that voltage equals current times resistance, and we can manipulate this equation to have it equal current equals, voltage divided by resistance and so on. And then we have the loop and node rules, which are backed up by the conservation of charge and currents, which basically state that the amount of current coming in is going to equal the amount of current coming out, and therefore the change in current will always be zero. For a brief preview and prediction of our results, the current in an RC current will be time dependent, and then the first constructed circuit of many in series will have a current of 0.020 amps. And some assumptions that we make to get these results include that the resistance of the wires and emitters is negligible in the virtual, simulated model. Onto the actual experimentation. Firstly, we construct a few varying circuits in series, all with kind of the same initial components of two 1.5 volt batteries, two ammeters, and two resistors. We can kind of manipulate this circuit in a few different ways. And then, secondly, we construct an RC circuit with two bulbs, one 9-volt battery, and a capacitor. And we were to measure the time it takes to charge and discharge the capacitor. And the system and the surroundings are going to be the same for both, or for all circuits and for both parts of the experiment, and that the system includes the multimeter and the surroundings are going to be the actual circuit. Okay, so the first circuit and the first part of the experiment were to construct a circuit with two 1.5 volt batteries, two ammeters, and two resistors. One of them it has 47 ohms and the other at 100 ohms. And after constructing the circuit, both of the ammeters measure a current of 0.020 amps, which is what we predicted and calculated just previously. And if the ammeter was inserted backwards, it would read the same value of 0.0 negative, or sorry, 0.020 amps, but this value would just be negative. And then this is the same circuit, but we switched out an ammeter for a voltmeter, which will decrease the current to 0 amps since this is not a closed circuit. But the voltmeter reads 3 volts, which makes sense since this is the total voltage of the two batteries combined. And then we close the circuit and then use the voltmeter to measure the potential difference at points A through H in the circuit, all with the net potential difference equaling 0 volts. And this graph is a visual representation that shows the potential differences, and it shows a decreasing trend. And then we create this same circuit as the very first one that we did, but instead of the ammeters in series, they are now parallel. And the current changes and it reads as 0.06 amps because the current is now being split and not experiencing the full amount of resistance. And then we calculated the new resistances for the resistors, and one of them is going to be 48 ohms and the other is going to be 102. Okay, now on to the second part of the experiment. We construct an RC circuit and immediately the bulb lights up and then dies out as the capacitor becomes charged, and the current will decrease to 0. And then when you take the battery out, the capacitor will discharge and light the bulb until it dies out again and the current will return back to 0. And I timed the charging and discharging for a 10 ohm bulb and a 20 ohm bulb and got these results on the left. And then we recreate this circuit with a 30 ohm light bulb and record our time results, and then linearize the data to get this graph with a slope of negative 0.1674, which we can then use to calculate the RC of the time constant, which is 5.989 seconds. And then we also calculated the theoretical RC, which is the resistance times the capacitance, which all comes out to be 6 seconds. So although there isn't a crazy huge difference in these numbers, there still is a difference, which can be attributed due to human error in recording the times, as well as the ammeter precision could be off. And onto the what if and why question. So what if you're doing this lab in real life and use an actual ammeter instead of an ideal simulated ammeter? What's different about a real ammeter, and how would it have affected the circuits that you hooked it up to? So a real ammeter would have some resistance instead of the virtual ammeter with 0 resistance, and so the current would decrease overall due to this resistance. And then, what if you were doing this lab in real life and used a real battery to charge a real capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? And explain. Discuss why the measured time is different from the predicted time. So, with no resistance, the capacitor would reach full charge immediately, yet this can't happen in real life since wires in the circuit would always have some small resistance, slowing this process down overall. Okay, thank y'all.